Okay, so with radicals, some of the stuff you should have seen before, some of it you might have even seen already in this class. Like we've already dealt with some radicals. What radical have we dealt with in here so far this year? Do we even know what a radical is? Okay. This symbol here is known as a radical. What radical have we dealt with this year? Yeah, square root. It's the most common one that you're probably used to. Remember, we did square root property when we were trying to solve quadratic equations. We have worked, and I feel like we did with something else. I can't think of what else, but I feel like part of our lesson I was trying to show you on your calculator how to find the root key, but I get confused sometimes. Sometimes I'm helping kids with other classes and stuff. But I feel like we encountered that in here. But anyways, if you haven't been formally introduced to a radical, whatever's on the inside that's known as a radicand can have numbers, variables, exponents, and then this guy here, which we may or may not have discussed, but you should have seen in Algebra 1, it's called the index. Okay, an index is not a coefficient. You guys think of, oh, but like the number in front of something is a coefficient. No, an index is part of the radical. Well, Mr. Romero, I've dealt with square roots before, and I've never seen a number out there. Well, yeah, well, there is one number that it's there, you just don't have to write it. And it's on a square root. On a square root, what number is out there? 2. Yeah, it's a 2, yeah, it's 1. But when the index is 2, meaning it's a square root, you just don't write it. So like, for instance, this is square root of 49. You won't see the 2 there, but it's there. What's the square root of 49? 7. One of the things we're going to start talking about are different types of roots. Okay, there's 2 main categories of roots, and it depends on the index, even or odd. Because a square root has a 2 here, what type of number is 2? Even. So a square root is an even index radical. You may or may not have seen cube roots before. Like, okay, that's a cube root, which you see over here. That's an odd index. And the rules for simplifying these radicals depend on the type of radical you have, even or odd index. This even indexes can have more than one root. You saw that with a plus minus with square root property. But whatever your calculator tells you, like unless you have an equation that you're trying to solve, like whatever your calculator tells you, that's the principal. It's called the principal. So like, hey, square root of 49, right? That's an even index. What this is telling you is that 7 times 7 is 49, which is true. But is there any other number that you can multiply times itself and get 49? Yeah, negative 7 also. Negative 7 times negative 7 is 49. So negative 7 is also a root of 49, but 7 is the principal root. Without indexes, you don't have to worry. So what this is a nice exercise in is using the calculator. Some of you don't know where to find your root key. I feel like I've gone over this, and like I said, it's the first semester. But if you happen to have your calculator out like you're supposed to every day, let's make sure that we know how to find these keys. Every calculator, every scientific, I think even 4-function calculators have a square root button. Now, once you start getting into scientific calculators, depending on the brand, some of them may have a dedicated cube root key. None of them have. I've never seen a 5th root key, but what they do have, the scientific calculators, is they have like a generic root key. Where now the only thing is that you would have to tell it to make that a 5. If you have a multi-line display, like when you turn your calculator on and blinks it, you should be hitting the 5 first and then. If you have a single line display, which I don't even hardly see, I can't remember the last time I saw it with a 1-line display. You have to hit the 5 afterwards. But what I want to practice here is just make sure you know how to find the button. If you take the 5th root of 32, your calculator should be able to tell you 2. If you take the cube root of 64, you guys look at that and go, oh yeah, that's 8. No, it's 4. So if you can't get your have to get to tell you that, then tell me that, and I can show you where to find the button. If you have a graphing calculator, you might have to hit a math, go into the math menu to be able to find those buttons. Like this is me giving you class time to find it, so you can't find it. You're gonna have to math button. So if you want the cube root, it's already there for you. So like for this last one, which is keyboard, it's already there for you. But if you need to hit the generic one for the 5, you have to hit 5 first, and then math root key. Anybody else need help finding their root buttons? Hit the math button, Keisha. No, you're not doing it. You're using square roots. 5, math, it says the math. This is the one there. Then this next part, I know that we had some experience in, so I'm going to go through this pretty fast, specifically because what do all of these roots here, what do all of those have in common? Well, they're all square roots, and square roots are the ones that we do have experience with. The other thing about them is some of these are not perfect. They're not perfect squares, but we also have experience with that. If you're trying to take a square root of a non-perfect square, what do you have to do? The tree. So we've done enough trees, and I'm boring some people whose names Brian with Benzo Brand. So just to speed things up a little bit, like if you do a tree correctly, this should give you 5 square root of 2. This should give you, I believe, 4 square root of 2. This one should give you 5 square root of 3. Now this next row is a little more interesting, but so we have practice with this also when we did properties of exponents. Square roots of all radicals are distributable over division. So this is the same thing as saying square root of 25 over square root of 54. Both those are perfect squares. Together, 5 over 8. Same thing with the next one. The only difference is that 8 is not perfect. So for the 8, you'd have to do a tree, which that tree would give you 2 square root of 2. But the 49 is perfect, which would give you 7. Here's another common cause for mistakes, and that's how do negatives affect your output, the radical. If you have an odd index, what are some examples of odd indexes? Cube root, fifth root, seventh root, ninth root. If your index is odd, don't ever worry about a negative. The negative is not going to have any effect on anything. With an even, though, it could. You've seen this, we've also covered imaginary numbers. But that's if the negative is on the inside of an even index. If I was taking the square root of negative 48, yeah, I'd be in trouble. Because it's an even index and it has a negative on the inside. But with a negative on the outside, no big deal. Now, 48 is not perfect. If you take the square root of 48, you would get like 6 point something, 6.8, 6.9. So you have to do a tree. I believe that tree gives you 4 square root of 3. I'm doing that in my head. You can double check for me. And then just because I have a negative already on the outside, that just makes the 4 negative. Cole agrees. You can go over the break. No? All right, cool. And this next part, this applies to variables. Like so up here, underneath these radicals, we didn't have any variables. These were all in constants. Okay, but what happens if you have a variable underneath and I have a meeting next period? It's one of the things I'm going to ask to see how much is enforced. Because to be honest, I've worked out, I don't really use textbooks here, but I've worked out different textbooks before. I've taught this in Algebra 1. And let's just say that the rules are inconsistent at best. In Algebra 1, I did not see this, when I went over this in Algebra 1, I did not see this stressed at all. And some books stress it more than others. But what happens if you have a variable that's underneath the radical? If you have an odd index, that's the word that goes there in the right? If the index and the exponent are odd, you don't have to worry about anything. Don't worry about any special rules. And all this is telling you is that if the index and what you should already know is if you take, we did this when we did our rational exponents. We have covered this here. Any radical can be rewritten as an exponent, as a fraction. That's the same thing as saying x to the a over b. And the exponent divided by the index. We went over that this year. Well, if that exponent and that index happen to be not only odd, but they happen to be the same, well, you're just going to cancel each other out because anything divided by itself is 1, and you would just get the variable. But if that the exponent and the index are even, when this x breaks out of the radical, it's going to need an absolute value. But again, like as far as it's a little bit more complicated than that, and the rules that I've seen attached to this are a bit inconsistent. I've seen different books give different rules, so I'm gonna ask to see like on your assessments how much this is going to be enforced. But I'll show you the rules for it. But as we get closer to that first quiz and the first test, I should have a more definitive answer for you. Yes, sir.
Will it be on the homework of Sunday?
It's not that. I mean, it could be, but from what I remember on Khan Academy, I don't remember seeing the absolute value. I get that. As of right now, it's more just I'm showing it to you, but I wouldn't be too worried about it. Even if it does come up, it doesn't come up. But here we go. Wow, perfect example. Look at this first one here. That says square root of 4m squared n squared. What type of an index is a square root? It is even, so if it was odd, I wouldn't be worried about anything, but it is even. And you should know from earlier that this is the same thing as saying square root of 4m. Now look, in the past I thought this gets taught at the same time as rational exponents, so I don't know if I mentioned it or how much we mentioned it. We should know what the square root of 4 is. And what's 4 is the perfect square? What's the square root of 4? Right? But then what the index does is that for the variables, in order to determine like what variables come out, they have to be in groups according to the index. Now, yeah, you're used to pairing these up, but what you may or may not know is the reason why you paired them up is because the index was 2. That's going to change the other radicals. So how many n's can come out? How many n's can come out? How many m's can come out? 1. How many n's can come out? That part we've done before. You do square root. We've done that before. Evan's done it before. But then now here's kind of the new wrinkle. The index was even. The exponents were even. So when you bring them out, you get an absolute value. Just variables, yeah. That would never apply to constants. And the whole purpose of it is that if a variable is an unknown number, a variable can be anything. So when you simplify an expression, you shouldn't be changing the value of it. So in order to maintain equality, in order for this to be the same as that, regardless of what numbers, if I were to say, hey, give me an M, give me an N, give me an M, give me an M, and you guys just give me random numbers, I should be able to put in the same M and N here that I do here, and they both give me the same output. And the only way that that would be possible would be with absolute values. What does an absolute value do? I'm sorry? Yeah, it makes a number, for lack of a, like, the simplest way of explaining it is it makes the number on the inside positive. But when it comes to square roots, or any even index, what potentially could happen when you have a negative on the inside? Huh? Well, you would get an error. You would get a domain error. It wouldn't be real, right? So if it wasn't for these absolute values, a negative here would give me an error. A negative there would give me a negative. Like, you can't get a negative out of the square root. Whatever's coming out of an even index would have to be positive. That just ensures that the variable stays positive. All right, let's look at the next one. Now, unlike the first one, 32 is not perfect, so you have to do a tree with 32, but we've done enough trees. See, this kind of starting to get bored. So we'll just go ahead and say, all right, with the 32, a 4 is going to come out. There's going to be a 2 left behind. 32 is a 4 on the outside with a 2 on the inside. How many x's come out? How many y's come out? None. So on the inside, this stays a 2 and a y. But wait, there's more. What type of index is this? Even. On the variable that came out, because if you have an absolute value, you want to be on the outside. You're not going to put an absolute value on the inside of a radical. So I have an even index, I have an even exponent, so hey, that x should take an absolute value, right? The short answer is yes. The longer answer, though, is no. And now, understand the reasoning here. Is there an absolute value there? Yeah, it's there. It's there. I'm not saying that it's not there. You just don't have to write it. Kind of similar to, all like 1 in front of the x. If I write a variable, but I don't write a number in front, what number is there? Well, there's a 1. Well, here, I don't have to write it, but yes, there is an absolute value there. Why don't I have to write it? A variable is an unknown number. An unknown number can be anything, right? What happens when you square any number? It's going to become positive. So really, the square is doing the work of the absolute value. I already asked you what an absolute value does. You told me it makes a number positive. The square is going to do the same thing. So it becomes redundant. You just don't need the absolute. Like, you don't need to write it, but it is there. If you were to write it there, fine. I wouldn't hold it against you. Now the good news is here now on this second line for the odd indexes, you don't have to worry about anything. It's going to be all right. Cube roots, like any other radical, I was gonna say it's distributable over multiplication, but I guess you don't really need to know that here. Um, just know that this is like the same thing as saying cube root of -8, and then 6b's. First thing you need to make sure is that you're not getting the square root on the calculator, because you're doing it to give an error. What is the cube root of -8? What is the cube root of? Try to see what's going to come out of this cube root. What is the cube root of -8? -2. Yes, you can get a negative with odd indexes. But now when it comes time to circle, and hey, look, you don't have to circle. You've already learned that you're just dividing an exponent by an index. But let's say you wanted to do it this way. If I were to do circles, what groups do they have to get in order to break out of this bracket? Yeah, they gotta get in triples. So how many p's can I bring out? 2. How many cubes? 1. Do any of those variables take an absolute value? None. Why not? Odd index. Odd index. With an odd index, you don't have to worry about this. The rules with absolute values. Any absolute value can only potentially come if that would even index. Okay, the next one. I'm not going to write out all these x's and y's and stuff, but how about the fifth root? Can we take the fifth root of 64?
Yes.
No, you actually can. I mean, you have to do a tree. It's not perfect. But here, I'll help you out. 64 is just 6 twos. So what can come out? Well, I'm going to bring out 1 2. I can circle 5 2s, but 5 2s on the inside is the same as 1 2 on the outside. How many x's can I bring out? 2. Yeah, 10 divided by 5 is 2. How many y's can I bring out? 1. How many z's can I bring out? None. Good. So now I have a fifth root. The inside is just 2 that stayed behind from the 64. And squared. Do any of those outside variables take an absolute value? Why not? Odd index. Odd index. Okay. Okay, this is just more practice with some rules, but let's see if we can get to this quick. Square root of -24 squared. Mr. Romero, you said on an even index I cannot have a negative, right? That's going to be an error. Because if you're doing order of operations and working your way from inside out, the first thing you'd be doing is squaring the -24. What does a square do to a number? Yeah, it makes it positive. Okay. This is another illustration of this property here. But now instead of with a variable, you're actually seeing it with an actual number there. It doesn't matter what that x is, positive or negative, but when you have an even index and an even exponent, especially when they're the same, yeah, they're gonna cancel each other out. But what's gonna come out is gonna be the absolute value of whatever was on the inside, which is really just 24. It becomes positive. See, you heard that? It becomes positive. Your dad knows what becomes positive, right? For the next one's easy, it's odd, you don't have to worry about any special rules. All that happens here, the cubes cancel, what are we left with? negative 22. How about the next one? We have a square root, we have a square.
X plus 1.
Yeah, it is going to be x plus 1, but even index, even exponent, even index, even exponent, that would be the next one. And I don't know what x is. And no, you cannot distribute an absolute value. You can't make it like absolute value of x. How about the next one? Somebody got this in first period. I was surprised. I think they were even less so we can do. Somebody got this. What should I do on the next one?
Factor.
Factor. If you were to factor what's on the inside, that is a perfect square trinomial. It's the same thing as saying y plus 8 squared. And once you put that in the square root, it becomes just like the one before. The square and the square root are going to cancel out. So Edwin, what are we going to end up with? It is going to be y plus 8. What else? If for some reason, like let's pretend that this were to be a cube and a cube root, then it would just be the y plus 8. There's no need for absolute value. But if they're even, absolute value. Such as the next one. What are we going to end up with on the next one? Just the m minus 4. On index. Right. These we've kind of we just finished doing them. These on your own if you want later on. But I'm just going to move on to the next one. See, you can do that one on your own. Raise your hand when you got it. Yes.
X squared. Square root. Cube root of
PX.
3x.
No. I would have, at the very least, I would hope you don't end up with all the tree.
Right.
So,
Yeah.
oh, no. Here, I'll help you out. I'll do the tree. Anybody have it now? Maybe not many answers are staying inside. We can see from the tree that there's a 3 that's going to come out. If there are 5 x's, that means I can bring out 1x. Because if I were to write these out, x, and it's a cube root, I can bring out one group of them. It is a cube root. I like that you said cube root. There's a 2 on the inside, but 2x left. That's squared. Do I need to worry about any absolute values? Odd index. And when you got it. Got it also? What do you got? Yes.
I got 5 and square root of 8.
She's closer. You should have an 8 in the square root of it. Okay. So you got to agree with the you should have been able to bring out, these are square root, so I can bring out a 2 and a 5, 2 times 5 is 10. So I did that perfectly fine. We also have 6 A's, so we can bring out 3 A's. That's why I did that. There are 3 B's that you can bring out. With a B left over, so she was looking at me now like, hey, Mr. O'Neill, that's what I just told you. Why you told me that it was wrong? Well, I didn't say it was wrong. I said, like, because it's a little terrible thing that she forgot to do. Where?
The B.
Oh, sorry, I forgot the 2 things. Yeah, I forgot to write the 2 units. Okay, but back to the absolute value.
Between the A and the B.
Well, just the A. The A. We have an even index, right? This is the square root. Look at the exponents. Which exponents were also even? The A. That's why the A needs it. Another way of kind of remembering it, if you have any of a variable left on the inside, it's not gonna take the absolute value on the outside. I'm gonna ask in the meeting next period to see how much that's gonna be enforced. Taken away with multiple choice. Does the absolute value show up in the multiple choice? Like I feel like it just doesn't. I want to say I saw the quiz, that first quiz before we left, and I don't remember seeing an absolute value, but the thing is out there. Any questions? All right, so that now blends into operations with radicals. Adding, subtracting, multiplying, and dividing. We can lump together multiplying and dividing because the steps are similar. Then we'll do adding and subtracting. This multiplying and dividing is more conducive to what you just saw with simplifying, so I guess we'll start with that. You can say it's easier if you want. We'll start with these and then we'll work our way to adding and subtracting. In order to multiply and divide, here's the other thing I need to ask. The indexes have to be the same. That's no doubt about it. In order to be able to multiply and divide, the indexes of the radicals have to be the same. But for multiplying and dividing, if they're not the same, then there's a way to make them the same. And I gotta see if those are gonna show up. Adding and subtracting, you can't. You have different indexes of adding and subtracting, you just say they're not like it, that's it. For multiplying and dividing, there is a way to make indexes that are not the same. There's a way to make them the same. But then once you get down to multiplying and dividing, if you're gonna actually multiply or divide, it's inside with inside and outside with outside. What do you think I mean by that? Inside and outside of what? Right. Please don't get this confused. Oh, you said outside with outside, and the index is on the outside, so are we supposed to multiply the indexes? No. What I mean by that is the coefficient. For multiplying, it's just 2 steps. And really the order doesn't matter, but I tend to do it in this order. I tend to multiply first, multiply this what I just told you up here, inside, inside, outside, outside. That's gonna get multiple radicals and all underneath one radical, and then I will simplify that radical. There could be exceptions to that rule, but typically that's how it is. Dividing becomes a little bit more intricate. Because dividing has 3 steps, and I list them in this order. If I can do it in this order, I will do it in this order. But really, I would say that it's about 50-50. Because sometimes you just can't divide it. That we might start with step 1, we might start with step 2. If I can't divide, I like to divide first. But there's going to be just as many times that you start to rationalize. And you might look at that and say, well, what the heck is that? And you shouldn't. This is the verb. It's to make something rational. That something is a denominator. We've done that already this year. Not other years this year we've done. We've done different types of numbers. Who remembers the types of denominators that we rationalize? Some of you remember. What were the types of numbers in the denominator in the first semester that we had to make rational? In order to make something rational, you want something that's not rational or rational. Okay, well, an irrational number is something that can be made rational. That's actually what we're going to do here. These numbers with the radicals are irrational. Now, first semester we did it with the other type of number that's not rational. Also starts with an I. With imaginaries, yeah, we did it with imaginaries. I would ask you if core members how to make an imaginary number rational, but that'd be asking too much, right? Remember how we rationalize imaginary numbers?
Oh, yeah.
It would be multiplying. No. It starts with complex and ends with conjugate. And you multiply by the complex conjugate. But here it'll be a little bit different. Anyways, so regardless of what step you start on, what I would advise you for the purposes of uniformity, I would go in this order. I would go straight down. But be aware that the only step that should never repeat itself is step 2. You should never have to rationalize twice. But if I start with dividing, you may have to come back and divide at the end. If I start with rationalizing, you may have to come back and divide at the end. But I would go in that order. And when we're talking about here simplifying a radical, if you want to be more specific, we're talking about the numerator. So here are some examples. We won't worry too much about this stuff here. This is stuff we know already. It just says that radicals are distributable over multiplication and division. Here, let's go with this first one. Square root of 3 times square root of 6. Even if I wanted to simplify those radicals, I can't. But I can multiply them. They're both on the inside. What's 3 times 6? But you can't just stop there. Now that I have them under one radical, if I can simplify them, I should. I'll just save the time from the tree. Most of you guys use your calculator anyways. For this next one, look, I like to multiply first. And everything here is on the inside. On the outside is only the ones, the coefficient. So this will be just 1 square root. The next step to be the same. So this is like a square root times a cube root. Yes, there is a way to change the indexes, but we won't worry about that yet. 10 times 5 is 50. For the variables, yes, you are multiplying, but it's going to feel like adding because when you multiply variables, you add the exponents. How many x's do I have in total? 4. How many y's? So now if I were to put this into a tree, I'd get a 5 from the 50, but I'm going to have a 2 left on the inside. I'll remember that 2 later. How many x's can I bring out? Yeah, I can bring out 2 x's. How many y's? Am I done? What carries an absolute value? You can say, oh, but the x has a square, the square is already doing the work of the absolute value, but the other reason, and this is where I've seen different things in different books. Some books say that the x would not carry an absolute value because at the beginning, it did show up in odd numbers. Even though once you multiply it, it became an x to the fourth. I've seen books that leave out the absolute value and start about odd. Let's look at the next one. See if we can at least get to this page. Fifth root times the fifth root. So as long as the indexes are the same, you can do it. That's the fifth root of 32 m to the fifth m to the fifth. 32 is a perfect fifth root. What's the fifth root of 32? 2. And then for the m's and the n's, you can just bring out one of each. You can include 5. Any absolute values there? No. Why not? Yeah, it's an odd. Yeah, odd index. For the next one, these are both cube roots, so you can multiply them. Cube root of 3 times 9 is 27. There's 2 x's. There's 3 y's. Cube root of 27 is 3. Can I bring out any x's? No. I can bring out 1 y. And then cube root of x squared. No absolute values because it's an odd index. Okay, now dividing is where it gets a little bit tougher. Okay, with division, if you can divide, I would try to divide first. I can't divide 81 by 16, but look at the variables. I can. If when we multiply, we add exponents, what do we do when we divide? We subtract, and I may have already shown you a shortcut. You do big minus small, and we know where the bigger one is. So like the 81 and the 16, I don't touch. But 4 minus 2 is 2. Leave it where the bigger one was. What's 1 minus negative 3? It's 4. 1 minus negative 3 is 4. Now I could distribute that square, the square root. The square root of 81 is 9. Square root of, like basically what I'm just doing is this. Just putting that square root of, oops. I'm just taking the square root of each. So this is 9xy squared over 4. Am I done? Did any of those variables take an absolute value? It was even everywhere before, it was odd on the outside. Here, this last one here, let's skip the next one, let's do this one here. Can 25 be divided by 8? No. So yeah, look, you do the square root of each, but if you're going in order, okay, I couldn't divide, what should I be doing next? Come on, let me finish it. Rationalize, right? So you may see that square root of 25 and you want to make it a 5, you can. The way you rationalize a radical, and you multiply it by itself. On the top, I'll get square root of 200. On the bottom, I'll just get the regular 8. To help you out, the square root of 200 is a 10 square root of 2. And then you can reduce it, let's get your 5 over 4. We're working on this one tomorrow.